Okay, good morning. Thank you all for joining us today. My name is Cliff Hawley. I'm the eCognition Sales Manager for North and Latin America as well. I'd like to welcome you all to today's webinar. We're going to provide you with a brief overview of the eCognition product. I'll be very brief with that. I just want to make sure everyone has a fairly decent understanding of what the product software offerings look like. And then I'll turn it over for the bulk of the discussion today to my colleague Jarlath O'Neil-Dunne. He's the director of the University of Vermont Spatial Analysis Laboratory, which is one of 8 universities around the globe that participates in Trimble's innovation program, TIP program. The way the format will go today, I'm going to provide, as I say, just a little bit of an introduction. I'll turn it over to Jarlath for the demonstration on how to automatically update your Vector GIS data using Trimble's eCognition software. As far as handling questions today, I'd like to make this a bit as dynamic as possible given the limitations of the time. So if you'll type your questions in, we will try to interject answers to those questions as we can. If it looks like it's going to be a bit of a detailed type of a discussion, we may hold some of that off to the end. And if required to go beyond our time frame for this particular webinar, we will, of course, download all of the questions provided and then respond to the group and individually with those answers. So we'll make sure all the answers our questions are answered. So basically, what is eCognition? Just a real quick overview. It's an analysis software for geospatial applications. The concept here, of course, is to be able to take real-world image data collected either in the form of images, elevation through LiDAR, or even surface modeling data through auto-correlated surfaces from imagery itself as well, and then ultimately getting to the point of extracting information products from your data in a manner that's more automated than the previous sort of manual digitization type of process. There's really sort of 2 basic thoughts or processes of utilizing the software. One is, again, this sort of extraction of information out of the raw data into this more usable vector form or you know, informational image data form, or bringing that information back and in a comparative sort of process or in a change detection sort of process, looking back at from the new data that's been collected to the older information that it's being compared against, again, as a sort of a change detection process. So what's specifically unique about the way that we do things with eCognition? One is that it's more of a data fusion process. It's going to allow us to fuse and use a variety of different types of geospatial data, such as images, point data from from LiDAR. These are the point clouds, vector data sets from your GIS, and then bring all of that information together into one cohesive data set so that all of the different geospatial aspects or the informational aspects of the data are being looked at one time. This is a dynamic process. Again, bringing in all of your data input, it walks you through a process of segmentation, ultimately classifying that data, allowing you to perform some GIS analytics on those new information products, and then ultimately abstracting that information to provide you with your choice of an export, whether that be a modified raster image, Esri GIS files, point clouds. Maybe you're just simply wanting to calibrate or classify rather your point cloud, or even maybe just a simple export in an Excel file. You just simply want to know percentages of some particular feature per lot, you know, in a particular data set, for example. eCognition products are offered to the market in sort of 2 fundamental offerings. One is the eCognition suite, which is the original product offering, and our newer offering, which is the Essentials product. I'll go into a little bit more detail on each of these, but essentially the eCognition suite is going to enable users to develop and execute their own custom solutions to transform their geospatial data into this information product, these actionable products that can be used further down the pipeline. The out-of-the-box capability of the application, this eCognition Essentials, takes the functionality of eCognition suite, but provides you with a very structured, and let me go into this a little bit more, but it provides you a structured and more simplified workflow. I'll get into that in just a second, but the eCognition suite is broken down into 3 products. There's the developer, which is the actual platform product where you develop and execute these, what we call rule sets. These rule sets are to use the lack of a better term, sort of a macro that allows you to take advantage of the toolkit of geospatial analytical tools that are available in the developer platform. It is a standalone product. With developer, you can write your rule sets, you can execute your rule sets, and you can produce these final output products. So in of itself, it is a standalone product, but it does require, it's a development kit. It does require you to develop these custom rule sets. We can get into some other discussions. There are rule sets out into the community that are available, which make it a very nice tool for sort of leapfrogging yourself into the product. But to distinguish yourself from the suite and the out-of-the-box essentials, it's just important to understand developer and the suite is a development toolkit and not an out-of-the-box, ready-to-play sort of product. With Architect, you can take these rule sets that have been developed in developer and then wrap a much more simplified user interface around this. We call it application wrapper around your rule set, and then be able to hand that simplified workflow out into the production environment so that folks that are wanting to use that functionality can focus on the data that's coming in and not have to worry about the rule set. It allows for what we call calibration of the rule set by slider bars, toggles, etc., to do slight manipulations on the variables that are in the rule set, but not substantively changing the rule set itself. And then finally, there's the eCognition server, and server is really your processing environment. This is your workhorse for the production institutions. This is where batch processing, the tiling of very large images, and then the parallel processing of those multiple images, folders worth of images, and then the stitching back together of the results into a single export, if that's your desire. But those are add-ons. So the server and the architect are both add-ons to the developer platform. And of course, then back to the essentials. This is essentially, if you want to get right to it, essentials is an architect solution where Trimble has written a predetermined rule set, wrapped it in an architect user interface, and then provided that more simplified, structured workflow to the community as a plug-and-play, out-of-the-box process or product for your land data cover classification type applications. Just real quickly before I turn this over to Jarlath, I wanted to mention that we do have several training events coming up. The first is going to be coming up and these are open seat trainings, by the way, so this is one of the better opportunities financially. If you're in the regions or can travel to the location, the price here is $350 per day, and that's a very good price for getting the training. So we have our initial 3-day developer server software training out at UC Berkeley coming up in May 18th of this year. UC Berkeley, by the way, is another one of our TIP schools, our TIP schools. Following that, we have 5 days broken down into a 3-day fundamentals class and the 2-day analysis, the analysis strategies. So really you're looking at how to put together all of the rule sets and the development of these rule sets, testing and executing of rule sets, and then ultimately the 2-day follow-on to that is geared towards how do I take this into a production-oriented sort of environment and really make it as fully automated as it possibly can be. So with that, I leave you my email. Please feel free to contact me with any other questions. And at this point, I will turn it over to Jarlath for the rest of the demo.
Great, thanks so much, Cliff, and good morning, everyone, or good afternoon, or good evening. Greetings from a rather rainy and uncharacteristically sort of mid-spring-like day here. It feels like in Vermont. I'm excited to talk to you, and I think really to give you some insight into what Cliff talked about, which is this data fusion approach within eCognition, and especially how you can use that to update your data sets, or what we often do quite often is use eCognition as a screening tool to find out problems with vector data sets, and then use eCognition to fix those problems and update those data sets. So like Cliff mentioned, what's really great about eCognition is you can bring in a variety of data sets. Those include your vector data sets, polygons, points, and lines, your raster imagery, and then even your LiDAR point cloud data. And it's really, I think, the only true sort of data fusion platform, because once you have these things that are image objects, they can have properties of all of those data sets. They know the attributes of your vector data, they know the properties of your imagery data, and they can compute things such as NDVI, and you can even do LiDAR point cloud metrics within your object. So it's really powerful. Now, I'd like you to walk you through a sample today of a rule set that I've developed that really just illustrates, I think, some of these basic concepts of data fusion and working and updating your vector data sets within eCognition. And so the starting point for this, I just wanted to show you this point cloud. This is just a sample data set that we're going to be working with, and then we're going to jump right into it. And as we work through this rule set that I've developed, I'll show you some of the other data that we're working with, because we're going to have LiDAR point cloud data, we're going to have building polygons, road lines, raster imagery, and then even some LiDAR surface models. So I think this is this characteristic jumble of data that we see nowadays. All of it has some value to it, but sometimes we may see things that are out of place or need updating, or they're just slightly incorrect. So I've jumped over now to the eCognition developer environment here. You can see that I've got a rule set here. And so like I said, I like to illustrate some of the basic processes for data fusion within eCognition, because I think this is really important when you want to start using eCognition to update your data. What I've got here first is I've got some routines to load in data. If we take a look at my project right now just consists of a LiDAR point cloud, okay, nothing more. And that's what you see right here, okay. eCognition displays the point cloud by default as just sort of its intensity layer. And so we see the characteristic intensity values sort of lower in some of the impervious areas, brighter in some of the other ones. But within our rule set, we can automatically load in other data sets. Okay, so I've got some leaf-off imagery here. I'm going to run that and load that in. Okay, so it's bringing that in, and what's really nice about eCognition, as long as my data sets are in the same coordinate system, they don't even have to be clipped down to the same layer. So here I've got a large image mosaic, but I'm only loading in one LAS tile, and eCognition virtually clips that raster data set down. I've also got some very large LiDAR surface models here. Okay, I've got first return, last return, raster surface models, and a DEM. So oftentimes we see this in LiDAR collects. You're provided with a lot of derivative products. And then I've got some vector data sets. Okay, here I've got some building polygons and some road center lines, right? And I'm going to load these data sets in. So what's nice about the eCognition developer environment and building these rule sets is that you can have automated routines that actually go out and grab different pieces of your data and then process, analyze, evaluate, update, and then export those data sets. Okay, you can even do some raster processing within eCognition. Okay, so oftentimes we think about doing raster processing in our traditional GIS and remote sensing software packages, but what's really nice is you can run algorithms. This algorithm is called the layer arithmetics, and I can simply take my two surface models here, my first return LiDAR surface model, which is at highest hit point, and my DEM, my digital elevation model, raster surface model, and I can do a subtraction, first return minus the DEM, to create what we call a normalized digital surface model or a height above ground model. All right, so I'm able to do this within eCognition. The advantage of this is that I'm doing it in my rule set. It's a temporary process, and I don't have to create all this hundreds of gigabytes of data outside of eCognition. Now, some other things I'd like to introduce you to are you can even do display updates in eCognition. So what's really nice when you're working in an environment is after you load these data in, you can have a series of algorithms that automatically update your display. So here I did a few things. The first thing that I did is I split my screen, and then I went ahead and I synced those two views together. Then I went ahead and displayed my imagery on my first pane, and then I went ahead and displayed that brand new, newly created normalized digital surface model on the second pane. So this is something I really enjoy about eCognition because I can build a rule set, and as I work through it, I can have these routines that improve my workflow efficiency, because being able to see and understand your data is just as important as the algorithms that you develop from it. So let's take a look at some of the issues here. So if you're familiar with eCognition, you can always change your display of your raster data sets. That's under this Edit Image Layer Mixing box. What some people might not know is in more recent versions of eCognition, you can also display your vector data. So here I'm just going to turn on my road center lines, which you can see there. They look to be pretty decent and fairly updated. And then here I'm also going to turn on my building outlines. Okay, let's make those a nice bright red. And I'm going to zoom in here on my digital surface model down below, and we can see here that a lot of our buildings look pretty good. Okay, we've even got some nice sheds in there, some nice planimetric data sets. But we move over to this area, it looks like there's been probably some construction and renovation. We had a large building here. Looks like part of it's been demolished and a new building's been put up. And here we have some other areas where there are buildings, but they don't seem to be included in the building data set. And quite often, in my experience, what we see are communities have an existing buildings layer, right? You don't need to do feature extraction for your entire LiDAR collect. You just want to find those areas that have changed. And you might just want to export that information as an attribute table that you can then bring up in your GIS and find the records, the unique IDs of those buildings that have changed. Or you might want to do some new building extraction. But like I said, you don't want to do that building extraction for the entire LiDAR collect, hundreds of gigabytes of data. That's not necessary. You've got really good buildings. You just want to focus on improving those buildings in the areas where they're missing. So with eCognition, you have a tremendous amount of flexibility where you can build customized rules that you're not just pressing a button on a building extraction algorithm and then trying to do a bunch of fancy GIS operations and overlays to clean up the resulting mess. You can do custom tailored algorithms that allow you to focus on specific aspects of this. And so I'd like to walk you through some very simplified examples here. And I'll stress again, these examples are highly simplified to illustrate the concepts, not to show you an extremely robust and flexible rule set. So let's take a look at this first issue here, in which we have some buildings that have, I'm saying buildings that have shrunk, right? In reality, what typically happens in these cases, someone's bought the property, they've demolished a building, and they've put up a new one, okay? So in this case, we see buildings that have sort of decreased in size, so to speak. So I've got a few steps here. The first thing that I'm going to do is I'm going to take my vector data here, and I'm going to make image objects out of them, because once I create these image objects, that gives me the full power of eCognition, where they have all the attributes that I talked about pulling through your vector data, your point cloud data, and your raster imagery. So when I go ahead and turn off those building layers, and then I'm just going to run some routines here that take those vectors and make them image objects. Okay, and we can see them there. I'll turn on my classification view up top here, and I've assigned them to this class, buildings from vector. Okay, now when I click on these image objects, what's really nice here is that they have a whole bunch of attributes associated with them. Okay, and I've put some of these attributes in here. For example, I can look at the mean value of the NDSM, okay, the mean value of the point cloud, that's the intensity. I can look at some customized features. Here I've taken the point cloud first returns and subtracted them from the last returns. So that's really, really neat. This image object is cutting through the point cloud and pulling out the elevation information, the average of the first returns and the last returns. I know how many building vector things it overlaps with. I know the unique ID, some of the thematic object attributes or vector attributes within the vector layer, that building's vector layer. All that information is now at my fingertips for me to work with. So as you can imagine, it's pretty powerful. But let's come back to this specific case here in which I'm looking to figure out areas where the building has shrunk, right? Looks like they've probably demolished the building and put up something new. So I want to find these areas. So the first thing that I'm going to do is do something called creating a lower level. Okay, so within eCognition, you can have objects at two levels. You can have a super level, and then you can have objects contained within them at a lower level. And what I'd like to do here is I don't want to delete these buildings here. I just want to find the pieces of them that are no longer buildings. Okay, so I can do that here by, on this lower level, running a segmentation routine, which is using the properties of my imagery and LiDAR data set to cut this area up into image objects. And each one of these image objects has all these properties associated with them. Now I can use some sort of simple classification routines to identify these objects and see which ones are not buildings on this lower level, right? So I would probably say, hey, you know, these things were called buildings, have a high value in that normalized digital surface model, they probably shouldn't be called buildings anymore. Now we can see that although I changed the classification on this lower level, the classification on the upper level remains unchanged. So this is one of the power of eCognition, is you can have what's known as these super objects and then these sub-objects here. And those relationships can be pretty useful. I'm just going to do some cleanup operations here, okay? But then I can use this rule here, okay, and I can say, if you're this class not a building, and we've got some routines here, right, we can go ahead and then classify you on this higher level, right? So let's identify these areas where we think the building has shrunk. So let's take a look at this rule here. This is a simple assign class algorithm. What I'm saying here is if you fell into this purple class here, which is buildings from the vector layer, and you have these green things below you, which is these sub-objects that are not buildings, I'm going to assign you to this building shrunk class. So what I've done here is I've identified buildings where they have shrunk, right? A portion of that building has been removed. And I did that by looking at the sub-objects here. So a very, very powerful routine in eCognition. And now what's also really nice about eCognition is I could go ahead and export this as a vector layer now, but perhaps I just want to kick this information out to my team as a comma-separated values, just an attribute table that they can then bring into their GIS and then find all these buildings where these changes have happened because they want to do some additional screening on that, right? So eCognition has some great functionality here, such as exporting object statistics. And what I'm going to export in this case is the records of those buildings that have shrunk. I'm putting them into a CSV file, and I'm including some attributes with them. I'm including the building ID attribute, so we can join this back to the original buildings layer within our GIS. And then I'm also telling them how much of that building has changed by using this relative area sub-objects that are not buildings. So what % of that has changed? And I'll take a look and show you that attribute table right now. I'll just slide it over here. It's a simple text file. Contains the inner X and inner Y coordinates here, the level it was on, the class, those building shrunks, this large number here, that's the % of the original building that's no longer a building, so about 80% of it, and that's the building ID, right? So it's easy to import this into my GIS, link it up with my existing attributes, and then find those buildings that have changed, right? A very, very simple way to do that. Going to run some cleanup operations here. And then those cleanup operations, all I did was sort of get rid of those existing portions of that building that were no longer buildings, just to make it look nice. And you can see now I've got this in this class, building shrunk, right? So I can begin to refine my actual vector data sets within eCognition as well, in addition to just exporting those attributes. Now let's take a look at another situation in which we're going to have buildings that are new, right? So we know that there are some buildings here that seem like they're entirely new construction, okay? And I want to handle these ones slightly differently. Once again, I don't just want to apply a building feature extraction algorithm to my entire data set because most of my buildings are good. I've just got select areas that have changed. And so I can use eCognition to extract those polygons, Or in some cases, if there's very, very few of them, what we'll just do if someone's doing a planimetric project, we'll just identify those new buildings, export them as points, and then someone on the GIS side can just go in and manually digitize them if that is the actual standard for digitizing those buildings, okay, or creating those buildings. So this is a really, really great way to screen your data and to provide your clients, customers, collaborators, what have you, with an idea of, you know, how much of your area has changed and how much should you plan on spending for updating your buildings. You can use those types of strategies. So in this case, we want to go and we're going to create a level above here. We're going to use these image object level routines. And the advantage of creating an image object level above is that what I want to do is I want to only find those buildings here that don't already contain buildings down below, right? So once again, I don't want to extract all my buildings in this area. I just want to focus on those select ones. And I'm going to do some very simple building extraction here using some easy rules. This is not how I typically do building extraction, but I wanted to simplify it so that it's easy to understand. First of all, I've just got a few rules that I put in here. I basically said if you're unclassified, and I put some criteria here, which is to say that the mean height has to be greater than 3 meters. You have to have a low value in difference between your first returns and your last returns because buildings are very hard surfaces, right? So tree canopy will have a lot of difference in your first and last returns of the point cloud. And then here we should also see little deviation in your returns of the point cloud, okay? And that's because buildings tend to be firmer surfaces once again, and unlike trees which have a lot of deviation. So here's a good example in which we're using attributes from a raster surface model and attributes from a LiDAR point cloud all integrated into the classification process. And we're going to assign these objects to a class we're calling building candidates here. Now they may not look perfect, but that's okay. We're just doing some initial screening at this point. We can then go ahead and merge those image objects together, and then we can go ahead and we can find those buildings that don't contain any buildings on a lower level. Once again, we don't want to go ahead and extract all buildings. We really want to focus only on those new buildings. And so that's where we can use this relationship between these two levels here, where on one object level we have the building candidates, and on the other object level we can say, well, if you don't have a high proportion of existing buildings, so either those buildings that were shrunk or those buildings from Vector, we're going to turn you back to the unclassified. And we can do some little cleanup routines here. And eCognition's got some really great processing algorithms. One I really like is remove objects. So I've got some false positives that are just out of the view here that are these really, really tiny buildings that I've identified. They're actually coniferous trees that are have LiDAR attributes that are similar to buildings. So I can just go ahead and remove those. There are also some light poles in there and things like that because they're false, and eCognition will just dissolve those into the objects with the largest relative borders. There's a lot of these processing algorithms you can use to clean up your vector data that I sort of wish, you know, the commercial GIS software packages had. Great. So let's do some additional routines here. So now we're going to go back down to this main level here, right? Because this is where we're doing all the work. We found these buildings here, and we want to really sort of get them back down. So we're finding those, and then we're exporting them, okay? So we've got these buildings that have expanded, and then we can go ahead here, and we can also export these things as these records, right? Because we've got some buildings out there that have simply increased in size. And let me scroll over, and this is an advantage of, this is a sample of that building here, right? We can see that this yellow area, this was the original footprint. It's called Buildings Expanded. We can see that it's clearly grown, okay? And once again, the advantage of exporting this as an attribute table is that I've got a record for my GIS team so that they know the areas that have changed, right? Okay, and then we can go ahead and do a little bit of cleanup there because we don't want to use that building anymore because we know that it's wrong. So now we're bringing those buildings down to our main level here. Okay, they don't look perfect yet, and that's okay. But one of the issues that we find here is that we've accidentally extracted a bridge. Okay, and this is pretty common, and this is I see these sort of issues all the time in some of these fancy point cloud feature extraction algorithms out there, right? I don't think you can pick up any sort of peer-reviewed journal, remote sensing journal in the last month and not find about a dozen new algorithms on building extraction. The problem is that a lot of them are not contextually aware. They're very good at doing local building extraction, but they're not good on incorporating additional knowledge. And so what's great about eCognition here is that we have a roads layer, right? Now we can see that there are roads here, and we could probably build some automated feature extraction algorithm to get at those roads, but we don't have to do that because we've got this great road centerline layer. And in our shop, we're a really big fan of grabbing data out there, whether it's from local communities or online platforms such as OpenStreetMap, because this data can really help you improve your feature extraction. So all we need to do here is do some sort of simple routines to begin to say, hey, are these buildings within roads, right? We shouldn't expect to see a building overhanging a road in most cases. So here we are, we're bringing stuff down, we're creating this new sublevel here, and I'll show you this here, right? We're creating this sublevel. I'm going to erase my classification on that because I retained that classification up here on the super level. And now I'm going to incorporate those roads here on the sublevel. And that's what you see there. There's road center lines. They're now image objects, so they have all the properties. And then I can incorporate a very simple rule here, right? So I can say that if you're one of these new buildings that I just identified here on level 2, okay, and you have roads underneath you, which means a road flows essentially through that building, I want to assign you to the bridge class. Okay, so a very simple way to deal with an error in my building extraction algorithm by using existing data, right? There's no reason to build a fancy set of routines to classify roads or bridges or things like that if you can use simple routines that rely on existing data. Okay, now I'm just going to clean some things up by deleting the levels that I no longer have. So now we've got our new buildings here, but the problem is they don't look that good, right? They're the product of a segmentation algorithm, and they don't look really, really clean. So we'd like to clean up all these buildings. We'd like to clean up the building shrunk one and the building's new one. So we can assign these all to a layer we're going to call, or a class rather, we're going to call buildings new. And then I'm going to make use of the vector processing routines within eCognition to clean these up a bit. Okay, so below here I'm going to turn off my classification, and I'm going to work with some of my vector layers here. I'll just turn on the original buildings so we can see them there. And the first algorithm that I'm going to run here is I'm going to convert my image objects to vector objects, right? So once again, the advantage here is that I didn't need to extract all my new buildings. I only wanted to extract some of those buildings. All right, so here I'm saying if your building's new, right, these objects here that are classified as buildings new, I'm going to write you into a brand new thematic layer called buildings new that are polygons. We see that here, and then when I go to my vector layer, you see that I have a new vector layer here. Okay, my new vector layer is called buildings new. Like we said before, they don't look that great right now, right? I probably could have improved my segmentation routines and done some more morphology, but that's okay because there's algorithms I can do within eCognition. For example, I can run a vector simplification algorithm, which, as it says in the algorithm description there, simplifies lines or polygons using, I don't know these two fine gentlemen, but I'm sure they did good work, right? So this simplifies the number of vertices. So I'm going to write this out to a new vector layer called buildings new, simplify there, okay, and then we can see the result of that. We'll make these perhaps some bright blue, right, and turn off the other ones here, and you can see that we've simplified these objects. They're still not perfect. We'd like to square them up, and so finally I'll run a vector orthogonalization operation here. Okay, this is going to take those simplified buildings and I'm going to turn them into more rectangular objects, right, so I can execute that. And so now we can view the output from these, make that a nice bright red color this time, and so then we've cleaned those buildings up quite a bit. And then I can export these as a separate vector layer for my team to review independently. I can go ahead and integrate them with my existing vector data sets and do some overlay operations within eCognition, but really the possibilities are endless here. So hopefully in this demonstration you gained an idea of a few key concepts, okay? One of them is this idea of automatically using your rule set to pull in all these different data types, keeping in mind that your only real constraint is that these data need to be in the same coordinate system. They don't have to be clipped to the same area. They don't have to be done at the same pixel size. You don't need to convert your vector data to raster data. None of that. You just need to have data in the same coordinate system, and you can automatically load it into your process in eCognition. Okay, some other things here, right? You can do raster processing in eCognition. You can subtract layers. You could use your imagery to create an NDVI layer. You can subtract LiDAR surface models to create normalized digital surface models, such as what we can do, etc. Okay, and then also updating your display, right? We can do things that improve our ability to work with eCognition quickly and effectively, symbolize our data sets and align our layout so that we can get to work quicker. And then finally, we can make use of all the different data sets that we have to do very constrained and focused operations that allow us to either query, check, or improve upon our existing vector data sets. And we can do those as object operations within sort of that native eCognition object format. And then finally, when we get to the end, we can begin to clean things up using some of the eCognition vector processing algorithms. And we have so many options to export the information. We can export them as vector layers, we can export as raster layers, we can export attribute tables, we can export screen captures, all different tools that different people in our organization may benefit from. So Cliff, I'll end sort of the live demo part there and see if we have any questions from our attendees today.
Great. Thank you so much, Jarlath. Yeah, at this point, if you have questions, please go ahead and submit those into the question pane, and we will make sure and get those answered for you.
Maybe everyone's just recovering from a raucous President's Day weekend.
Exactly. Okay, well, I'm not seeing any questions yet at this point. If questions aren't, well, hang on a second. They're starting to come in. Let's see.
It must be someone we paid off.
Yeah, exactly.
They just said excellent presentation. So your check's in the mail.
Maybe, let's see. How come the segmentation doesn't recognize the fairly straight lines of the DSM or height model so well?
Yeah. Sure. No, that's a good question. So in this case, actually, I segmented on the imagery alone, and really I did that so that I could show you that when you have flawed image objects, like we had, you can use the vector processing operations to clean them up. If I had segmented them based on the LiDAR surface models, they came out looking too good, and you really didn't get to see the results of the vector orthogonalization and simplification. So that was an intentional error. So this, I think, brings up a really good point. What's really nice about eCognition is that in some cases, so for example, for buildings, you may want to segment on your LiDAR surface model, right? It's got really clear lines along those edges, but then maybe you're also mapping impervious surfaces that are not buildings. And in that case, you may want to segment on the imagery. I think that's what's really nice about eCognition is it gives you the ability to control what layers that you use in segmentation. And I'll just bring that up quickly here. I think, let me find one of the places where I had done some segmentation. Yeah, here we go. So you can see here under your image layer weights, right, you can choose which layers that you want to use in your segmentation. And that may be just the imagery alone, it may be just your LiDAR surface models alone, or it might be a combination of the two. And quite often when you're doing something like building extraction, it's also good to include a slope layer, and you can use the raster processing functionality within eCognition to create a slope layer, and that also helps you get those really clean and nice edges. So thanks for that question. I think, Cliff, I don't know if the next one is...
Sorry, I have a question here from Charlotte saying, can you show us how to view the point cloud data and raster data in 3D?
Oh, sure. So So eCognition does have some point cloud viewing capabilities. Okay, so there's a 3D viewer here. All right, so that allows you to do some 3D views within eCognition. All right, so you can see that there. I'm a huge fan of eCognition. I wouldn't say that this is the best LiDAR point cloud viewer out there, but it can be handy if you want to go ahead and take a look at your point cloud in 3D. So once again, just like you can view your vector data, you can turn things on to view your point cloud data in 3D, and then you can change those point cloud settings. So those are all available to you.
Okay. There was also a question here about whether or not eCognition can run in the Amazon Web Services environment. The answer to that is yes. Particularly in our more recent releases, we've actually finally finished up a formal testing in our engineering department. So we're very confident now that that software can indeed run in that environment.
Great. Thanks, Cliff. Let's see. Someone asked, why did you take the first return instead of the last return for the DEM? Sorry about that. I don't think this is really clear. The DEM that we imported was actually a generated DEM in which the point cloud had classified ground returns. So the contractor in this case ran an algorithm and did manual edits to assign ground points to class 2. And then what I did, I think this relates to my layer arithmetics here. What I did in my layer arithmetics here is I took the first return LiDAR surface model, so the highest hit points, and then I subtracted the DEM, which are the ground returns from those, to create this normalized digital surface model. So hopefully that clears things up. You know, what I really like about eCognition is there's just so many different ways of approaching the same thing, right? You saw in some cases here I was using the raster surface models. In some cases I was using the point cloud. The options are really up to you. I can see the other ones here. Can eCognition classify bare earth in a LiDAR point cloud? Yes, it can. So if those of you who are on the eCognition community, I know the eCognition development team has posted some really nice examples of that. I would say right now, most of the LiDAR data that we see, particularly here in the US, comes with the ground returns classified. What we typically see is that it's missing the other classifications, and eCognition is really handy for that because we can bring in, especially when you're looking at doing a point cloud classification on buildings and tree canopy, having imagery data is such a help. And if you look at a lot of the point cloud algorithms out there, which I'm a huge fan of, there's some great software packages out there, great people doing point cloud algorithms, but if you're not using imagery, you're really not using as much data as you could, as much information as you could to make those decisions. That's what I like about the point cloud classification with an eCognition. Next question was, can you briefly go over how you build the algorithms used in the demo? Yeah, so sorry, I made some sort of assumptions here that a lot of you were sort of perhaps familiar with eCognition before, and I guess depending on sort of the questions we see in this webinar, we might back up and do some more basic ones. But eCognition really is this development environment. It's a collection of algorithms, and what you do when you have your rule set, and I'll just go ahead and you know, delete my rule set here. And what you do is you just append a rule here. Oops, sorry, I realized my screen was paused there, sorry. What you do in eCognition is you append a rule, and then you choose from all these algorithms that you have, and you've got thematic layer operations, these are your vector processing operations, you see your image layer operations, those are your vector algorithms, all the way up to your segmentation algorithms. So it's really like this code base that you use, and you can stitch together these algorithms in any way, and it gives you a lot of flexibility in terms of your feature extraction process. Someone asked if these rule sets are available. Yeah, we can package this one up, and I'll get the data packaged up in the rule set and then post it to the eCognition community and probably put it on my blog as well. Someone else asked, how does the software work with oblique photos such as those come from pictometry? I haven't used any oblique photos within eCognition. Cliff, do you know anyone who has?
I'm not familiar with some of the stuff that's coming as far as use with the pictometry data sets. Of course, with a lot of the vertical takeoff and landing UAV type data coming out. I know there's more and more clients starting to try to look at that data, so it's still a little bit early for me to be able to say what the results have been.
Okay, thanks. Yeah, I know certainly in our case we're using point clouds collected from UAS, so drone point clouds, photogrammetric point clouds, but I have not, I'm sorry to say, used pictometry or the oblique data. Next question, someone asked, could you use your LiDAR class data? Yeah, that's a really good question, and let me see. I'm just sort of working through things. I deleted my rule set there, and now I wish that I had it back. So one of the things that I can do here, let's see. Let me just find a segmentation really quickly here. We can. Oops, sorry. I should probably run these things in order here, but I just want to show you pretty quickly. Even if I just click in one of these buildings here. Here, I think I've got a. I can go here and select features to display, and so what you can do here is you can go to object features, you can go to point cloud features, and then you could say you could grab the number of points, for example. You can grab the number of points from your point cloud from all returns, and then you can filter by selected classes. So maybe I would like to see the number of points in every single class but ground, okay? So I want to see the number of points for that, and then we can scroll down here, and here you can see this building has 3,445 non-ground points. So this is what's really cool, is that you have access at the object level to all this information in your point cloud, and then you can do customized things, like you can say, take the number of points that you have in the ground class and subtract that from the number of points you have as first returns, right? You can filter by elevation, all those types of things. Another question about the rule set being available on the community forum. Yeah, we'll get it up there along with the data. Does eCognition actually classify the point cloud using imagery? Yes, you can use eCognition to write in a point cloud classification, right? So one of the things you could do is, and we do this sometimes quite often, is we'll do feature extraction. For example, we'll extract buildings and buildings and trees. We'll export those as vector objects. We'll export them as raster land cover classification, and then we'll go ahead and also write that classification to the LiDAR point cloud. So you can have multiple exports all within a single eCognition environment, which is really great and handy. Let's see, the other one here. In the analysis preview lower window, limited to the current view to enhance performance. Are the rule set operations applied to the entire extent of the data set? Yes, so one of the things I didn't cover, but perhaps I can go out to my workspace view here. So what you can do in eCognition is you can create these things called subsets. And so I'm going to go back to my full project here. Okay, so I was actually working with a subset, and the advantage of a subset is it allows you to develop and test these algorithms in an on a subset of your data where things go much quicker. And that's really handy because some of the algorithms that we have, like segmentation algorithms, take up a lot of memory and can be sometimes time-consuming. And we're working with really large data sets here, especially when we're talking LiDAR point clouds, right? So here I can use this thing subset tool. I can select an area. I can save that subset to a workspace, okay? So it's going to produce a brand new subset here. I can then go in, open up that subset. So the subset's a virtual clip of my data. I can then take that other rule set that I was developing, okay? And even though the data were not all clipped down to this area, right, I can go ahead and run this here and, for example, load in all my data from before. It covers the same extent, just a lot more. I don't have to clip all my other data. eCognition's handling that for me. I can do my raster processing operations, like generate that normalized digital surface model, and I can go ahead and update the display. All of that becomes available within this new project. So hopefully that answers your question. Have you used eCognition with coarser rasters? Yes, you can. So a good example of that is maybe there's an existing land cover out there. So in America, we have a USGS product called the National Land Cover Database. It's 30 meters, it's Landsat derived, it's pretty coarse, but in some areas it's really useful. For example, knowing is there agriculture in the general vicinity, right? So you can do that. You can bring those layers into eCognition, and it'll just resample them to whatever the smallest cell size is, right? So I could say, you know, does my building fall within an area that's classified as agriculture? And maybe that's information that then I use to help inform my classification. I've mainly used that to look at false impervious surfaces. So sometimes in high-resolution imagery from a single time point, you have these large fields that look like parking lots, but maybe you've got existing coarser land cover data that says, hey, you know, this is an agricultural dominant area. We don't expect to see agriculture here. We can use that information. Or perhaps you've got a parcel database with those things. Let's see. How effective is the software in working with nothing more than imagery and an auto-correlated surface for feature extraction? That's a good question, and really that's a combination of how complex and heterogeneous your landscape is, and then also how good are you with eCognition. Generally, my point of view with eCognition is if you can clearly see something, then you can probably build some rules within eCognition to handle that. And what I like about it, especially now that we're seeing this increase in photogrammetric point clouds from UAS, and you've got existing UAS imagery, is that you've got a lot more flexibility to do your feature extraction without having to rely on these canned algorithms that are heavily dependent on LiDAR properties of the point clouds. So it can be done. More data is always better. You know, multiple returns for a given pulse are always better than a single return, but we've certainly done that type of feature extraction, and especially having any type of surface model is better than no surface model. And there's a lot of things that you can do, right, like computing slope over your surface model, and that'll find those hard edges, and then you can find those areas within those hard edges of a consistent elevation. That's often the sign that it's a building. So hopefully that gives you some pointers. What's the recommended amount of RAM to fully utilize eCognition? I think the specs contain, say, like a minimum of 8, but really my recommendation if you're buying a new computer, try get at least 32 gigs of RAM. If you're getting heavy into multiple if you're talking about processing multiple LiDAR point clouds at the same time in a distributed environment, and we do this, right? You're talking about combing through hundreds of gigabytes of point clouds, you're going to want to go over 100 gigs of RAM in those cases because you're loading a tremendous amount of information into memory. Are there other products out there that perform the same tasks? There are a lot of, and I'll say this just as sort of an academic who I think is rather unbiased, there's a lot of automated feature extraction products out there. My criticism always is that they're very tend to be focused on imagery or LiDAR or maybe just raster data. As far as I know, eCognition is the only platform that allows you to bring point cloud surface models, imagery and vector data all together. And I'm not saying don't use those, right? There's a lot of great point cloud classification algorithms out there. We'll sometimes run those. We'll run the point cloud classifier in a different software package, and then we'll bring the classified point cloud into eCognition with the imagery, and then we can actually fix a lot of the errors within that classified point cloud from which spectral information gives us the key indicators, right? Sometimes you have trees that just in the LiDAR data for some reason look like buildings. You bring in the imagery, clear as day, they're vegetation, right? And so that information can really help you out. eCognition Essentials package capable of multi-core processing. Cliff, do you mind if I turn that over to you since I'm mostly a developer user?
Yeah, definitely. The Essentials package can use multi-core processing functionalities on the segmentation process. So getting through that, which is usually one of your more exhaustive processes to begin with, we've given that process the multi-core function capability.
Great, thanks. Yeah, and that's been one of the nice improvements I noticed in the latest releases of eCognition has been multi-threading for your segmentation that really speeds things up, and also gives all of you out there justification to tell your organization to buy you new and fancier computers.
Well, and that exactly, but and that's up to a maximum of 4 cores. So within the product itself, as is, you can take advantage of up to 4 cores, and then beyond that you'd start looking at the functionality that would come from your server environment, the eCognition server.
Yeah, and I think maybe, Cliff, if there's interest, we can look at doing a webinar down the road that sort of talks about eCognition and its batch processing functionalities, because really what I'd like to show you folks next is, of course, how do you take something like this when you've got 200 LiDAR tiles, right, these image mosaics, and integrate it into a distributed processing environment where this algorithm just combs through each one of those LiDAR tiles and, for example, is just kicking out the attributes of all those buildings that have changed. Because that's really one of the great things about eCognition. I think one of the shortcomings of a lot of the other feature extraction software packages out there is they're really not designed for the enterprise. They work great for small subsets. That's why you see a lot of times in the peer-reviewed literature, everyone's working on 5 kilometer by 5 kilometer areas. You know, we've used eCognition to process, you know, either hundreds of gigabytes or sometimes terabytes of data. I think we've got another question here. Are there any good workflows in eCognition on how to handle trees overlapping buildings? Yeah, so that's a good question. I mean, it's certainly a tricky thing, but what you can, especially if you have a point cloud, what you'll notice for those trees is that typically the lost returns that you'll see underneath those trees are going to be the building roof, and then you'll have some other ones in there. So and this is where you also see a lot of the point cloud algorithms will fail, but what you can do is you can use that point cloud to sort of, especially if you rasterize the lost returns, that can be a nice thing to visualize it, and so that allows you to see those areas under the tree, and then you can assign those, and we'll do this quite often. We'll do sort of building extraction based on largely the lost returns of the point cloud, and then we'll do canopy extraction based on the first returns, and then you can have that portion of that tree that overlaps the building assigned to the tree overlap building category. So that's definitely possible, and something I think where eCognition is probably your best solution for that. I think, Cliff, we're nearing the end here. I'm not sure who gets to call it quits.
We are nearing the top of the hour. Looks like at this point, at least, all of our questions are answered. If something else comes up in thinking about today's examples and demos that you'd like some more information on, please feel free to reach out to us. We do offer through the website a free downloadable demonstration license for the software. That's both the developer and the essentials. I always give this caveat just due to past experiences. The demo that you can download is free and has an unlimited time frame. There are some limitations to its use in that any developer rule set that you create in this demo license is not usable in a paid license down the road. It's an excellent tool for testing out the software, running through some of the tutorials, familiarizing yourself with the workflow and the functionality. If you find that you need to demonstrate or utilize the software in a full functioning way that's savable and that you can take your exports out to show your management or whatever, let me know. We're very happy to provide these trial licenses of 30 days, give you a chance to ring out the software in your environment and export anything that you need to export for management review. I'll answer this last one. We are recording this for today, and we will provide the link for that for this recording on the community portal, as well as the data set from Jarlath. All right. Unless there's any other last-minute questions, I'd like to thank all of you for attending today. I know there's a lot of things going on in your day. We appreciate you taking the time out to join us. Jarlath, thank you so much for a very informative and captivating presentation. And with that, I will sign off from this event.